Welcome to lesson number 6. We have problem solving with polynomial products. So in this example, we have a Haida Bentwood box, and we want to use a polynomial expression in order to write expressions for the volume and the surface area. So first of all, we know that volume is equal to length times width times height, and it has a length of 5x minus 2, a width of 3x minus 1, and a height of 3x plus 1. So you want to write and simplify an expression for the volume of the Bentwood box in centimeters cubed. So my volume is equal to 5x minus 2, 3x minus 1, and 3x plus 1. So if I want to, I can simplify this by carrying out FOIL. And when I carry out FOIL, I'm just going to do 2 at a time here. So I'm going to start with these first two, 5x minus 2. So I'm going to have 15x squared times negative 5x. Then I have minus 6x times positive 2. And then I'm going to multiply this by 3x plus 1. And so these two terms I can simplify right away. So what I'll be multiplying is 15x squared minus 11x plus 2. And then I'm multiplying this by 3x plus 1. So 15x squared times 3x, I'm going to get 45x cubed. And then I have 15x squared plus 1, so plus 15x squared minus 11x times is going to be negative 33x squared minus 11x. And then I have plus 6x plus 2. So if I simplify this, I get 45x cubed. And then I have minus 18x. So minus 18x. And then I have minus 11x plus 6x. We're going to have minus 5x plus 2. Now we want to write an expression and simplify our expression for the surface area of our Bentwood box. So the surface area of a rectangular prism, because that's essentially what this is going to be equal to 2 times the width times the length plus the height times the length plus the height times the width. So we're going to have a pretty large expression here, but my width was 3x plus 1, so minus 1 times my height, which was 3x plus 1, plus my height, which is 3x plus 1, times my length, which is 5x minus 2, plus my height, which is 3x plus 1, times my width, which is... Oh, actually, I should do my 3x plus 1. I should do width and length because I skipped one, actually. So let's make this minus 1, and my length, which is 5x, minus 2. So as long as everything is multiplying everything else at least one time. So now I'm going to have 3x minus 1 times 3x plus 1. I'm going to have 9x squared. And this is a difference of squares here. So it's going to be minus 1. And I'm going to add 15x squared. So 15x squared minus 2x is 6x minus 5x. Sorry, plus 5x is negative. Actually, let's go negative 6x plus 5x minus 2 plus 15x squared minus 6x minus 5x plus 2. Now we can add our like terms together. So 2 times I have 9x squared plus 15x squared plus 15x squared. We're going to have 39x squared. My x's, I have negative x here and negative 11, so we have negative 12x, and then my constant terms, negative 2, positive 2, negative 1 is going to be minus 1. And so my surface area is going to be 2 times 39. So if I just simplify everything in my brackets, I got to distribute my 2 in. So let's distribute that in. That'll be 78x squared minus 24x minus 2. Now, if x is equal to 20, we want to calculate the surface area and the volume of the Benedict box. So in my original expression, we had 45 times 20 cubed minus 18 times 20 squared minus 5 times 20 plus 2. All right, so in centimeters cubed, we have 352,702 centimeters cubed, and with our surface area, I should use my original equation, 78x squared, sorry. So 78 times 20 squared minus 24 times 20 minus 2, and we get 3,718 centimeters squared. For part B, all we need to do is substitute our value of x with 2.5. So this would be 9 times 2.5 squared plus 34 times 2.5 plus 28. So in our calculators, we have 9 times 2.5 squared plus 34 times 2.5 plus 28. And we get 169.25 units. Last, we're looking for the hypotenuse of a right triangle is 5x plus 5 centimeters long, and the lengths of the other two sides are 4x plus 8 centimeters and 3x minus 5 centimeters. Now what this looks like then is if we have a triangle with a hypotenuse, that means it's right angled. So we have 5x plus 5 is my hypotenuse, and the other two sides are 4x plus 8 and 3x minus 5. So we want to form an equation and solve it to determine the lengths of the three sides of the triangle. Now we could use Pythagorean theorem, which tells us that the hypotenuse squared is equal to the square of a and b added together. So 5x plus 5 squared is equal to 4x plus 8 squared plus 3x minus 5 squared. This would equal 25x squared. 5 times 5 is 25 plus 50x plus 25. This should say 50x plus 25. And then we would have 16x squared plus 64x plus 64 plus 9x squared minus 30x plus 25. Now what we need to do is combine our like terms. And so I'm going to get all my x squareds together and all my x's together as well. So 25, I'm going to bring everything to one side of my equation, set it equal to 0. So I'm going to have 0 is equal to 16x squared minus 25 plus 9. So 16 minus 25. So I'm taking care of my x squareds first. This is going to be 0x squared. So these are all going to cancel each other out when I bring them to the same side. 50x, I'm going to bring it over here. So subtract 50. So 64, subtract 50, and then subtract another 30. Gives me negative 16x. So taking care of these terms. Then I have 25, or 64, and I'm subtracting 25 to this side. And then I'm adding 25 to this side. And so I have positive 64 here. And so that's after I've simplified all of my like terms. And I'm going to add 16x over here. 16x equals 64, and x is equal to 4. So that means for the, let's see, the hypotenuse of my triangle is equal to 5x plus 5. But if x is equal to 4, then that's 5 times 4 plus 5, or 25 centimeters. We'll call it, we'll call that side, we'll call that A. So A is equal to 4x plus 8. 4 times 4 plus 8 is equal to 24 centimeters. And side B, which was 3x minus 5, that's 3 times 4 minus 5, or 7 centimeters.